You can also, I didn't put it in there. You can also think of this like a vending machine, right? You put in $1, you push the button, and then suddenly the same kind of food would pop out, presuming that you don't run out of food, right? So I put in $1, I put in F2, I get a bag of chips, or whatever the case is. I have a certain input, I will get a consistent output based on that input. You've done it before, you do it everywhere in your life, it's just more clean when it comes to the mathematics. So we're going to look at the basic concept. I'm going to go through a metaphor palooza later on. It's a whole lot of different metaphors that we're going to be looking at. And we're going to see how we can reuse our code, because I don't want to have to I don't have to write the same piece of code over and over and over again. I want to be able to reuse it. We'll also be able to see how to pass parameters in, take parameters out. We're going to look at local and global variables later on. And we're going to look at libraries, how we pull in other libraries using other people's functions. Okay, so here is how we are going to declare a function. We will have some kind of return type. That's the very first part of the parameter. Then we'll also say what things going in are. So int foo char a. Char a is an input parameter, the thing going into my function, like the x in f of x. And what gets spit out for f of x was a number. Well, in this case, it's also a number, but it could be anything. So my inputs for this next example are a character A, a character B, and it's returning an integer. So character A, character B go in here, and then I'm going to return some integer, so I'm casting A from a character to an integer and returning. My functions and my variables need to be declared before use. So here's my declaration of a character A, here's my declaration of a character B. Those are going to be set up to something. And my function itself, I'm going to define, I normally have like a little prototype, a one-line preamble, if you will, a one-line stubby of what this function is going to look like, what the function is. We'll look at that also as well, how we structure our code. Just to give you something crazy, this was an assignment question that was way too hard for my students last fall. What I was looking at, because I thought it was cool, and I spooked a lot of people. What we were trying to look at is if you pass me in an integer between 0 and 31, can you convert it to a binary number? So if I pass in, if this value is dec to bin of, let's say, 7, what do I get? Well, this thing is going to be equal to 1, 1, 1. Now, that technically is 100, the value was 111. Um, the value is going to be technically 111, but really what I wanted was the binary representation, which is a 1 plus a 2 plus a 1, a 2, and a 4, which is actually equal to the value 7. Dec to bin of 9 was going to be equal to 1, 0, 0, 1, right? 1001. But it is the binary representation, right? That is how I would represent it in binary. So I'm returning an integer, but really I'm faking it. And it's going to be a bunch of zeros and ones. What this thing is spitting out in the end, it's a bunch of zeros and ones representing the binary number. That's what I'm playing with. Okay. Now, we didn't have functions at the time of doing this, so people were doing it sort of uh, manually. And we did it for like 4 numbers. So you take this approach you take, and you'd copy your code, Control C, Control V. You copy your code 1 time, 2 times, 3 times for the 3 different numbers you're going to convert. But what you really want is some function where something goes in, like the number 9, and the proper number spits out. And you don't have to worry about how this works. It's a magic box. The number 9 goes in. The binary representation of 9 pops out. We're good to go. That's what I'm wanting. That's what I ideally wanted. That's what we are aiming, at least the students were aiming for. Now, we didn't do functions, but this is what a function would look like. And what we could do to get this, by the way, if you're trying to figure out what the algorithm is you take your number 9, you have some kind of multiplier value sitting around, and you have this binary value that you're going to return. So I take my multiplier value, which starts at 1, then becomes 10, then it becomes 100, then it becomes 1,000, when it becomes 10,000, and I'm just going to multiply. I'm going to figure out if I take my original value, 9, divide it by, figure out what remaining 2. So 9 mod 2 is what? That's going to give me 1. Then I multiply it by 1, so that gives me 9. So this is 9 mod 2 is equal to 1. And then I multiply by my multiplier, so bin value here is equal to 1. Then I divide 9 by 2, and so it starts off at 9, and now this is going to be equal to 4. 4 multiplied by 2 is equal to 8, and there's remainder 1. Okay, so my val divided by, and then I change my multiplier, so it's no longer just 10, it's no longer 1, it's now 10. I multiply by 10 each time. So I take my value 4 mod 2, which gives me 0, multiply it by 10, which gives me a grand total of 1. That's what my new binary value is. Then I do it again. So my value is, I'm going to divide it by 2 again. So my value is going to be, it's no longer this, it's going to be the value 2. I do that, then I do the 2 mod 2 multiplied by 100. What's the value there? Oh, it's still going to be equal to 1. And then I do it one more time, and I'll get 1001. I just iteratively keep on dividing by 2 each time, and then I have a multiplier to increase the size of how big this number is. It's a way of doing this conversion from binary to decimal, but we're using a computer, not by hand, just in case you wanted to figure out what the heck this thing does. When we start getting for loops and while loops and stuff, it becomes even easier. You don't have to repeat code at all. But what I wanted is something that takes in a number, spits out the binary representation. This would be one way of doing it. One other way of looking at functions, in case you're not a math person. I'm not a car person, but let's just look at this. So here's a decomposed car. If I talk about my car, what I do not want is sort of a whole bunch of weird interactions of everything. I want little individual parts that do their job. Each part does its job correctly, and there's no interaction. I want to be able to reuse parts. I want to reuse that bolt all over the car if it's the right bolt for the job, right? I want to reuse this particular kind of, I don't want different kinds of spark plugs in my car. I want just the one type. I don't want different kinds of tires. I want 4 tires that are exactly the same, right? I want to build my car a particular way so I can reuse parts. And I don't want interactions. So if I roll down the window, the horn shouldn't sound. If it does, I should get the hell out of the car because it's a dangerous car. Like, there should be no interactions like that, right? When I rev my engine, it shouldn't, suddenly turn on the air conditioning, right? That's an interaction. That's really weird. What I want is each part does their job. Each part connects to the next part. So when the engine, the output of the engine then goes to the axle, which then powers the car. Whatever the case is, like there's a number. Yeah, you can tell I don't know what I'm talking about. But all your car parts, one part will then go to the next part, which then goes to the next part. So when you push your foot down on the accelerator, a series of parts communicate one to the other from the input from the foot going down to the next part, which then gets that output from that part to the next part, all the way down to the car moving. The parts are as simple as possible, no simpler. You're trying to keep things as simple as possible, and you're composing a much, much more elaborate thing using a bunch of small little parts. That's what we're looking for. We don't want one monolithic car. We want a bunch of parts that you can swap out, replace. If there's a problem in some part, you can figure out where it is. Reuse of things saves you time, saves your sanity. You do not want to have to reinvent how a wheel is made, or how a spark plug works, or how this works, or how that works. If it's custom made for that one particular car, no one's going to be able to fix it later. Okay, and you'll also notice for us, input and output, this scanf and printf, that's the exception. It's not the rule. Your car doesn't take most of your parts of your car don't worry about user input. They take output from some other part of the car and they output to some other part of the car, right? The engine is not directly listening to the user. It is getting a whole bunch of things to finally get some kind of input from the engine where more gas goes to the engine. It is not directly the user changing the amount of gas to the engine. For the vast majority of things, we got some kind of input going into the function, some kind of output, and there's no printfs, there's no scanfs. I want to be very clear about this. And if we're looking at the engine, and I say that, or I'm trying to think of the exhaust, and I say that bolt is broken. What bolt am I talking about? There's a lot of different bolts in the car, right? There's a lot of different various parts in the car. If I say that bolt without even pointing at anything, what do you assume? You assume it's the bolt I'm looking at, right? Or the part where I'm looking in the car, that's where you expect the bolt to be, not somewhere else in the car, because that would be stupid. So when we're talking about functions, we'll see that again. This is a prelude of things to come. We're going to be talking about scope next time around, and that's what I mean by that bolt is broken. That where you were looking when I say variable x, I mean the variable x for where you're looking right now. We'll see this in action, but just I wanted to preamble things or to expose you to that idea early. So much like a car, all the parts do their own little thing, and I want them to be independent of each other. They do their own thing. You don't want a whole lot of interaction effects with the various parts of the car. If something breaks, you want it to break in one place, right? If you have a problem, you can deduce what the problem in the car is based off the symptoms because each part does their own thing. Here's the other approach. This is sort of the mathematics approach, right? The black box metaphor. We get a bunch of values coming in. These are technically only numeric values or data going in. The variables themselves do not go into this function. The function has variables that are set at the beginning, but data is going into the function. So I got a bunch of data going into the function. Some magic happens. Something gets spit out the other side. Right? You go to KFC, they bring in a bunch of chickens, magic happens, the Colonel's secret recipe gets put on, you get a bucket of chicken wings, right? Or whatever the case is. Think of some whatever metaphor you want. You don't want to know how this actually works. In fact, that is the dead giveaway for this part right here. Do I know how my car works? No way in hell. Like I'm painfully ignorant about how my car works. I know enough to change my oil. I know enough how to, fill my car with gas. I know something a little bit about, how the car is actually operating. But I can't fix things in my car, nor should I. I can use my car. I can drive it. Not well either, but I can drive my car, but I don't want to know how the internals work. I just want to use the car. Same with the function. I want input going in. I want to know what goes out. I don't want to have to know how it's doing it. If you tell me this thing gives me the absolute value of a number, I want to take it on faith that it does give the absolute value of a number, which is if it's negative, it becomes positive. If it's positive, it stays positive. You give me an array and it finds the smallest value, or the smallest value in a list of numbers, right? The function is find smallest or min, right? You pass in an array of or a list of numbers, it returns the smallest number there. I don't want to know how it works. I shouldn't have to look at somebody else's code. The function's called min. I can read the comment at the top and I know what it does. That's the black box model of a function. I want something that does the job. I break down the problem into sort of meaningful chunks, not all willy-nilly everywhere. This does the minimum. This does this. This does this. It makes sense that all of my code does this one particular job. I want to break down big problems into these little chunks that I can string together, not one monolithic piece of, just one monolithic pile of code. I want to specialize, I want to group common code together, put it in a function. So here's my general format. I have some kind of return type on the left hand side, much like a function for just f of x, right? Cosine of 60, right? What's going to be returned? Here's my function name, which would be like cosine, and the parameter going in, 60 for the case of cosine of 60. So things go in, I don't want to know how cosine works, or the square root would be another function, right? I have a function called square root. It takes in some value, it spits out some number. I don't want to know how it calculates the square root. Good enough for me, right? Something goes in, something comes out. The function will execute line by line. So I have a function, it gets called, I execute line by line in my function itself. So line by line, I go through my function line by line all the way down, and then I return some value, and then I stop my function. So here is average of 2. It takes in one value, it takes in a second value. So val1 will be set to something, val2 will be set to something. It will then calculate what the val1 plus val2 divided by 2. It'll save this into value 3. It will then return a double at the end, that val3. So I could call, let me see here. So val1 will be be assigned the value 2. Val2 will be assigned the value 3. I will do add 2 plus 3 together. I would then divide by 2. That should give me 2.5. Val3 is equal to 2.5. I return 2.5. My average, the value for my average here, is equal to 2.5.